Hello, and welcome to the Ohm's law and power sources example. Now this example is very similar to the passive sign convention example that you probably just watched, but there are some differences, and in particular I've tried to include both voltage sources and resistors in this problem to make it clear exactly where the energy is coming from in the system. So if we look at part A, you can see that there's a 30-volt source. Now the first thing that's very important for you to recognize is that if you have a voltage source that's drawn like this, the longer line on top is the positive terminal, and the shorter line on bottom is the negative terminal. In fact, that shorter line on bottom is sort of a reminder for me because it looks like a negative sign. And so that helps me to remember that it is, in fact, the negative terminal. Now, that positive terminal on top wraps around to also become the positive terminal on top of the resistor. And the negative terminal wraps around to be the negative terminal on the resistor as well. After all, there's no voltage drops along the wires, so therefore if it's positive on the top of the voltage source, it has to be positive on the top of the resistor and on the bottom as well. We can also see that the current is flowing from left to right along the top. We can expand that out and we can show that the current is actually flowing around the entire circuit going sort of clockwise. Not sort of clockwise, exactly clockwise. And that tells us that the passive sign convention is satisfied. You can see right here that arrow is flowing into the positive terminal and everyone is happy. And so therefore that tells us that the unknown quantity is drawn in the correct direction. That means that therefore the current is going to be positive. So we know the voltage. We know that the voltage is 30 volts. I can draw a voltage of 30 volts plus to minus. Always include those polarity indicators whenever you write a voltage. 30 volts plus to minus, I know the current, therefore the current has to be equal to V divided by R, which is going to be 30 volts divided by 6 ohms. And therefore that is 5 amps. And that will be a positive number because the passive sign convention was satisfied. Looking at part B, it's actually a little bit easier because the positive and negative are already explicitly shown. You can therefore write the positive terminal of the resistor up here and the negative terminal of the resistor down here. We can see that the current is again going to be going clockwise. It doesn't always have to be drawn clockwise, but many times we will show the circuit with a clockwise current. And again, you can see that the passive sign convention is satisfied. Current is flowing into the positive terminal. And it better be because the only thing that's unknown in this circuit is a resistor. Resistors can never be negative, so therefore if you have a circuit with the resistor as the unknown, you better hope that the voltage and the current obey the passive sign convention. So here the resistance is going to be V divided by I, which it turns out is 9 volts divided by 3 milliamps. And this works out to be 3,000 ohms, or as an electrical and computer engineer would probably write it, 3 kiloohms. We often deal with numbers that are so very large and so very small that we like to list things with prefixes to try to make them a little bit simpler. Looking at part C here, you can see that we have a current that's unknown, but very subtly here, the voltage source has been put in backwards. So remember that the positive terminal is for the longer line and the negative terminal is for the shorter line. Now we see that the current is flowing clockwise again, and the negative terminal on the resistor is on the top and the positive terminal on the resistor is on the bottom because there's nothing in between the voltage source and the resistor. So therefore the arrow is flowing into the negative terminal. Therefore the passive sign convention is not satisfied. That means that the current is drawn with the wrong arrow direction. It should be flowing from right to left on the top, but it's just backwards. Not a problem. That means we just need to include a negative sign. So I'm going to say I equals negative V divided by R, which is equal to negative 10 volts divided by 5 kiloohms, which it turns out is negative 0.002 amps, or again, negative 2 milliamps is the preferred way of representing that for a circuit analyst. Looking at part D, again, the voltage is put in backwards, but it's also unknown. So I can have the positive terminal here, I can have the negative terminal here on the resistor, and clearly the current is flowing into the negative terminal. Passive sign convention is not being satisfied, and so therefore I'm going to have a negative voltage. So when I calculate V, it's going to be equal to negative I times R, which is negative, in this case, 3 milliamps, times 2 kiloohms. I love when the milli prefix and the kilo prefix cancel each other out, and that therefore leaves us with negative 6 volts. Again, this just gives you a little bit more practice working with the passive sign convention and with the fact that sometimes unknown quantities are drawn incorrectly. And if they are drawn incorrectly, it's just important to remember that therefore the values will turn out to be negative. Appreciate your attention.